All right, here's our video. We are running out of helium. Well, are we running out of helium? That's where we put the question mark, right? Oh, yes, we're running out of helium. And some scientists put it as 30 years we should be running out of helium, which is kind of strange when you think that helium, which is the second most abundant element in the universe, second most, is very rare on Earth. So it's out in the universe, it's in our sun, but very rare on Earth. So the next question we might ask is like, well, does it even matter if we run out of helium? Well, if you're looking for a helium balloon, it does matter. When you go to Party City or wherever and you can't find a helium balloon, maybe you will be upset. Well, there's other reasons for helium. We'll talk about them in the video. But first, let's get our pen ready. What is helium? We can do a Bohr model of helium. Niels Bohr, he made models of the atoms. So, we in helium we do have two protons. We'll put them as positive charged, and we'll use another color. We use that color. Then there's two neutrons, two protons, two neutrons. They have no charge, and that's the nucleus, right? And it's surrounded by one orbit, and it has two electrons in one orbit. So helium is a noble gas. It's very noble, acts noble, right? It's also called an inert gas because it doesn't react. So it only has one ring. It has one orbit, we can say. One orbit. Some people call it ring. Some people call them shells, right? It has one, just like hydrogen. And it's full because you only could put two in the first shell. So the last shell is the valence electrons, and it has two, so it's completely full. That's why it does not react. So inert means it does not react. It's not reacting with anything. Like hydrogen is very reactive, right? You'll hear things like hydrogen peroxide or hydrogen chloride, but you'll never hear of anything like helium chloride. It doesn't exist, right? Helium does not react with anything. Does not react with anything. It likes to be alone, right? So think of the other reactive gases and reactive metals like sodium is very reactive. The alkalis are very reactive. Think of them as, hanging out in Vegas or the Hamptons, and think of helium hanging out in some small, quiet New England town. It does not want to react. Okay, clear that out. Like I said before, it is the second most abundant element in the universe. Hydrogen is the first in the universe. Right, first came hydrogen, then came helium. It's also the second most lightest. Right, we think of it as a light gas because our balloons, you put helium in a balloon, it'll go up. Well, there's helium, that's the symbol He. But if you put hydrogen in a balloon, it'll go up also. And I'll go over why we should not have hydrogen balloons, right? That they could be dangerous. But so it's the second most abundant element, second to hydrogen, which is first, and the second most lightest, second to hydrogen, which is also the lightest. Okay. Now, in our atmosphere, if you think about it, again, it's rare on Earth. Rare on Earth. In our atmosphere, we don't have 1% in our atmosphere. We don't even have 0.5%. We have about this percent. 5/10,000ths of a percent of helium is in our atmosphere. And of course, since helium is less dense than oxygen, it will just escape into space. So where is it found? So it's found in Earth's crust. So I'll put Earth's crust here. And it's found, what's happening there? It's found in Earth's crust, but it's found with natural gas wells. So, and the largest reserve is in the United States. It's in the USA. Right? We account for about 78% of that hydrogen in these natural gas wells. And of course, in the United States, one of the largest reserve is mostly in Texas. So we get them from these natural gas and oil wells. And let's just clear this out. So when they're digging in these gas wells, they'll come across some hydrogen, and it's not that much anyway. Look, and hydrogen comes from uranium decay. You might have heard of uranium and thorium. So uranium decay, and here's the problem: the decay rate for that could take billions of years. So it's not like we can make helium. We can't make it. We cannot make it. So whatever there is, that's it. So here's a map of some of the things where we find some helium, and you can see it's just centered a lot around Texas, Oklahoma, Kansas. Around this area, you see a lot of that helium. And of course, we say a lot of helium according to the map, but we are running out of it. Well, let's look at a periodic table on helium. All right, get our pen going there. So you can see, hydrogen's way over here. There's the hydrogen. And then on the same row, you have helium. So these two elements, right? These were the first two elements in the universe. And then the lightest is hydrogen, then the lightest is helium. Third lightest is lithium, but we can't use lithium because it's a metal. Hydrogen is not a metal, hydrogen is a gas, right? And so this whole row here, all this right here, these are noble gases, and these are very inert. They don't react. They don't react. Now, because hydrogen is very reactive, it's dangerous to have them if you're going to use hydrogen in, like, let's say a party, in hydrogen balloons. Yes, they will rise up in the air, but they're flammable. So that's why you don't use hydrogen, right? Any kind of spark might blow up, right? It might cause hydrogen to blow up. Like the Zeppelin, remember the Hindenburg? If we look at the Hindenburg, it was made of hydrogen. Right, so here's the Hindenburg full of hydrogen, right? So it blew up in Jersey, right? This German Zeppelin. So that's why today all blimps use helium, and that could be a problem in the future, right? There's going to be no blimps using helium. So that's why we don't use hydrogen, even though it is lighter than helium. It's reactive, right? So also, we use helium in other devices. So let's list where we use helium. By the way, this is the cover of Led Zeppelin, right? Led Zeppelin 1, I believe, 1969. So we can't make helium. So what we have is what we have. So, but it's used in medical equipment, especially if MRIs, they use it because, again, it doesn't react. And here's the interesting thing about helium. Let's put this up. Helium stays cold. It stays cold. What do I mean by that? It's the only element on the table. It's the only element that can't turn solid. And that's why they use helium, because they know it will stay cold. It will not turn solid. So they use it for a lot of super cold applications in physics, in the military, and so forth. So it will stay cold and it will not turn solid. You'll find it in LED screens for your TV, for quantum computing, which is getting bigger. Quantum computing, for example. All right. And of course, superconductors, super cold magnets, um, fiber optics, medical research. Helium is important for that. And of course, our balloons, right? We want them for our balloons. A kid doesn't care anything about that. He just wants his helium balloon. Again, if we had hydrogen just with the H, you might, just a little balloon of hydrogen, it might get a little pop or a little flame, but it's very unpredictable. So you're not going to have that happen. And so the last thing we'll talk about is, what about your voice? When you put helium in your voice. You can't do that anymore if we run out of helium, right? We make our voice sounds like Mickey Mouse. Well, the reason that happens is so inside your voice, the sound waves in your voice, they have to go through oxygen, right? They have to go through the air. In helium, though, it speeds up. So that's why, and it's 3 times faster. That the sound waves are moving faster in helium. That's the reason why your voice sounds weird when you're inhaling helium. So let me just change the pen. Just say so in air. So you put helium inside you. The sound waves will move about around 1,100 feet per second, roughly around that. It's a little more than that. But in helium, He is helium. Remember, in helium, it'll go over 3,000 feet per second. So it's the speed that the waves can travel that's going to change your voice. But again, if we run out of helium in 30 years, we wouldn't have that. All right.